Hey everyone, hope you're doing well. So yeah, we're working through Eloquent JavaScript right now, and the goal is to work through chapter 2. So chapter 2 is all about program structure. So this is like running your program top to bottom, if, for loops, that kind of stuff. And we'll touch a little bit into functions, but really that's next chapter. And then it's hard to like talk about a lot of this without interacting with things like objects and arrays and things like that. So just like the last chapter, I'll probably try to break out and kind of talk about some stuff that you'll learn kind of going forward. And hopefully it'll be a help to everyone as well. Okay, so program structure is what we'll talk about. Before we get going too strong, I do want to talk about my fundraiser right now I'm doing for childhood cancer. The really cool thing right now is this year, St. Jude is making a massive push to help with international care for kids across the world. Many developed countries have ready access to medicine, but that doesn't mean that we should just ignore the rest of the world that doesn't. And so this year in particular, they're putting a lot of their resources and efforts into spreading their cancer research and actual resources around the globe. And St. Jude is really the leader in childhood cancer survival and a lot of the research that's done. The cool thing about St. Jude is, unlike a lot of research hospitals, they're not trying to keep their research proprietary. They really try to share it openly so that it can benefit everyone. So I'd love to have you join me. The cool thing I think is I have like maybe 7 people who have sent me their receipts. So you have to give at least $5 and send me your receipt. And I have like 38 prizes. So at this point, basically, if you give, you're going to win one of these things. And so if you give just $5, plus you get to help kids with cancer, you can read a lot more about St. Jude, how they use the funds. All that's super open and public. And so that's one of the reasons I've partnered with them for the last several years. And you all are always so generous. Last year, we raised $3,600. This year, I'm like, I'm going to go for it. And I think that they'll follow. I think that those who watch will want to give. So we still have a lot to go. We're halfway through the month. So I really need some help to get us across the line because my goal is to get to 5K. And again, I've got like $7,500 worth-ish of prices to hand out to those. These are basically donation incentives. So they kind of encourage you to give. And a huge thanks to all the companies who partnered with me to do that. I've got several things from Cloud Cannon, Console Ninja, which automatically log stuff in your console, Git Tower, which is all about working with GitHub or Git itself, wherever your stuff is stored, Dracula, which is a theme editor, my own Learn Astro course, Mux, which is a video player. It's really like the only way I would use videos on the internet right now. Neon, Quokka, Vercel, Wallaby, Warp, and yeah. And Mux as far as like if you're building a platform or something like that. So I use this for a course or things like that. I'm going to use it for my my own like Astro, what am I calling it? Advent of Astro here that I'm going to do at the end of the year. So I'd love to have you join me there. And yeah, let me know if you have any questions about that. Okay, I think we're all set to go. And it looks like audio is working. So let's jump straight into program structure. And again, I'm going to try to kind of just walk through this as I would myself if I were walking through this without reading every single thing. So I might skip over some stuff, but let me know if you have any questions or if something doesn't make sense. Okay, so beginner JavaScript, we're talking about 2 different things, expressions and statements. And these can be kind of confusing when you're learning. So hopefully I can make sense of this for you. So in chapter 1, we talked about values. We mostly talked about numbers and strings and booleans, I think, and a couple other things, but that was kind of the core ideas, like the different types of data you can work with in JavaScript. So now what we're going to talk about is how to structure your code. And essentially stuff runs like top to bottom. Oh, and I actually thought it might be useful to go to the bottom of this and just walk through what we're going to learn so that, let's see, where are we at? Summary right here, so that we kind of have a path ahead. So it's going to tell us that a program is built out of statements, which themselves can sometimes contain more statements. Statements tend to contain expressions, which can be built out of smaller expressions. Not super helpful, but it's summarizing what we've learned so far. So we're going to learn about statements and expressions. Okay, secondly, putting statements after one another gives you a program that is executed from top to bottom, which is usually how JavaScript is run. There's obviously some complexity there, but you can introduce disturbances in the flow, and this is where those complexities come in using conditionals like if or else or switches, or by looping, by doing things like while or do or for loops. I'll give you a hint. Most people don't use while and do too much. Usually you can get away with for loops only, but yeah. Bindings can be used to file pieces of data under a name. We talked about that a little bit last time. Variables where you can basically say like, hey, store this here. The environment is set as a set of bindings that are defined. JavaScript systems always put a number of useful standard bindings into your environment. And in other words, there are several that are built in by default, and we'll look at some of those too. Functions are special values that encapsulate pieces of a program. So you can invoke them by writing the function name and then passing along different arguments that the function might need. Such a function call is an expression and may produce a value. So we're going to learn about expressions, statements, like conditionals, looping, how to bind things to variable names, and then a little bit about functions. So there's a lot to go over in this chapter, but hopefully we can make sense of it for those of you who are just learning. Okay, so up top here, expressions versus statements, or not versus, but and statements here. So any fragment of code that produces a value is called an expression. And this is important, especially once you start to get to frameworks like React, because there are certain things you can only do with expressions or only do with statements. And so this is helpful to know. All right, so every value that is written literally, like 22 or psychoanalysis, I'm not sure why that's the word they chose, is an expression. So basically any just value here can be an expression. This shows part of the beauty of a language-based interface. What are they talking about here? An expression between parentheses is also called an expression, as is a binary operator. Okay, we don't need to worry about that. Okay, if an expression corresponds to a sentence fragment, a JavaScript statement corresponds to a full sentence. So think about it in that kind of analogy. So an expression is like a little fragment of a sentence, whereas a full sentence is what we would call a statement. So a simplest kind of statement is an expression with a semicolon after it, like this, a semicolon. This wouldn't really do a whole lot. In fact, if I try to hit play, I don't know if it's going to even do anything yet. So it can't really do anything, but technically this is, something, although like they say here, it's a useless program. The statement does stand on its own. And we'll talk a little bit about these semicolons. Maybe they actually even do in here, I'm not sure. It may display something on the screen, as like with console.log, we did that last time, change the state of the machine in a way that will affect the statements that come after it. The changes that happen are called side effects. And those are important both because you need to know what they are, because they can really mess with you if you don't, and also because you can use them to your benefit. The statements in the previous example just produce the values 1 and true and then immediately throw them away. So this leaves no impression on the world at all, so there's no real side effects at all. So what we want to do usually is produce code that has side effects, like, hey, add this number up for me, and it adds it and returns to you actual values. In some cases, JavaScript allows you to omit the semicolon at the end of a sentence, sentence statement. But in most cases, it has to be there, or the next line will be treated as part of the same statement. Right now, I wouldn't really worry about this too much. Most of the time when you're writing in a code editor, it has this automatic semicolon insertion where it'll add that for you. The big thing to know here is like when a statement, which we'll look at in a second here, like if it doesn't have a semicolon, that it'll like continue to use the next lines as part of that statement. So we'll look at that in a second. Generally speaking, though, it will add those things for you, so you don't have to worry about like when do I add a semicolon and when do I not. And if it's adding it where you don't think it should, then that tells you that maybe you don't understand your program yet. All right, bindings. This is a way to keep internal state, like basically memory. How does JavaScript know what's going on, what you've done before? And this is by using bindings or variables. So for instance, you could say let caught equals 5 times 5. If I come over here, it's not going to play anything here, but I could come down and say like console.log, which is a function that JavaScript gives us to write things to the console. I could say caught like this. And now it will go grab that value and print it out here for me. And I can see that it's stored the actual result of this. And this whole thing is called a statement. All right, so that gives a kind of statement. It's this, gives us a second kind of statement. The second word, keyword, let, right here, indicates that this sentence is going to define a binding. I just realized my screen is like on the wrong side, and I think that's going to drive me insane when I'm assuming it would you, so I'm going to assume it will me too. So let me move this over. I'm going to move my face over here, and then maybe I'll move this up top so you can actually see that. Okay, cool. I don't know how perfectly aligned that is, but that will at least allow me to look the right way. Andrea, welcome. All right, we're going to call that semi-okay. Can you still see? I think so. Okay. So the example creates a binding called caught and uses it to grab a hold of the number that is produced by multiplying 5 times 5. That's what we just looked at here a second ago. After a binding has been defined, its name can be used as an expression. So I can just use this expression 10 times 10, and it will use this and basically grab the value from here and insert it in the place of its name here. When a binding points to a value, it doesn't mean it's tied to that value forever. The equal operator can be used at any time to like change that value. We'll talk a little bit about different types of keywords that will or won't let you do that, but you can see here we start with it at mood and we log it here. So now it should be set to light. Then I change mood to equal dark, and now I console log it and it should say dark. So in other words, you can switch what a let variable points to in memory. You should imagine bindings as tentacles rather than boxes. They don't contain values, they grasp them. Two bindings can refer to the same value. And a program can access only the values to which it still has a reference. When you need to remember something, you either need to grow a tentacle to hold onto it or reattach one of your existing tentacles to it. I like the idea of not talking about them as boxes because that helps get away from a lot of errors you can run into when you're first learning. The tentacle idea is a little hard to wrap my mind around personally, but we talked about this a little bit last time, but let's walk through this and then maybe I'll jump into that example. So remember the number of dollars that Luigi still owes you, you create a binding, all right? His debt is 140. When he pays back 35, you get this binding a new value. So it's equal to whatever it currently was originally minus 35. And if we were to run this, I can come in here, you'll see it's now just 105, which is what we'd expect. All right, when you define a binding without giving it a value, the tentacle has nothing to grasp. So it ends in thin air. If you ask for the value of an empty binding, you get undefined. All right, I'm not sure how I thought they were going to continue on from that. But in other words, when you don't give something a value, so for instance, if I came in here and said like, I don't know, let something, and I don't give it a value, then when I come in here and I console.log it, or I try to grab the value out of it, and we'll just log it to show what the value is, and I grab something like this, oops, it will still say, hey, I have a binding called something, but I have nothing in it. So it gives it the key word undefined. So this tells you that you have something actually declared, but there is nothing here. Now, if I were to say like something two, which doesn't exist, what do you think would happen? Well, you might remember that we talked about both undefined and we talked about null, but here it's just going to say, hey, this isn't defined at all. I can't reference anything here. So you actually have to, this is saying it exists. This first one here, right here, this says, hey, this exists. However, there's nothing actually there, no value there. So that's what undefined means in that case. All right, let's see if let's look at this example. If I can get this to work. Let's come over here. I think we talked about this last time, but let's see. Why is this thing? Here we go. Okay, so this is like the spot in memory where the value is held. Maybe we would give this thing a name as well. So we could call this name. And up here, I think we talked about this last time. This would be something like Chris. So this is the string Chris, and this is the spot in memory. Essentially, that's holding that. And my program can reference different things. So I can come over here and say like, let's console.log, and I'm gonna log name. Let's see if I can move this over. Now, when I do this, the JavaScript is gonna run out and say like, hey, do I have any bindings or variables called name? And if it does, it's gonna look at name and say, hey, give me whatever you point to. This is the idea of tentacles rather than boxes. So this is the spot in memory, but the name is what we're going to reference. We're not going to reference like a specific spot on memory. We're just going to reference it by its name. The name then reaches out, the variable, whatever that happens to be, reaches out and says, hey, memory, give me whatever you've got. And it says, oh, I've got Chris. And I say, if I can type here, I say, oh, perfect. So it gives it back to me. Then the variable returns this. And when I console log it, it will just print out Chris. Now, it may be that I have this. Let's say this is a let variable. We'll talk about different kinds in a second. So let name, all right, equal, and it's going to equal whatever this memory is here. But I could also change that. So if I came along later and I said, hey, now I want name, instead of this value being Chris, I want it to be Joe. Well, now the next time I come into here and I say, hey, give me the valuable name, whatever value you have for name, it'll jump out, grab that from memory, return it to me, and now it's name. So in other words, this spot in memory can switch, but the name I reference it by, which happens to be name, which is confusing here, is the same, all right? So I could say like person or whatever. So the name I reference this variable or binding by is consistent. It's just that what's in memory might change. So keep that in mind as you're referencing things in your program. Right now, you just need to know that that can happen. You don't need to be able to, write it yourself. Okay, there are some other words here. Let statement may define multiple bindings. This isn't done super common, mostly because it's just it can often be confusing when you're reading a program. But you can see here that I say let 1 equal 1, comma 2 equals 2. So technically I have two variables that are both let variables. 1 equals 1 and 2 equals 2, the number. The words var, const, and const can also be used to create bindings in similar fashion to let. Long story made short, don't use var. It's kind of an old way of doing this, and there's some issues we'll run into, I'm assuming they'll talk about later, with scoping, like where you can access the variable. Const is usually my default, and then let is usually only when I know I may want to change that binding. There's some differences, but basically const is a constant. We talked about this a little bit last time, but things like numbers and booleans and strings, once they're set with constant, you can't change them. So as an example here, let's get rid of this. If I tried to change this here, it's going to yell at me. So if I say greeting equals like bye, and I try to run this, it's just going to yell at me and say, hey, you cannot assign something new to a constant that's a string. Now, if this were a let, I could do that. So if I play this, nothing should be returned because I'm not returning anything here. But now a greeting is going to point to this string bye. Bye will be the thing that's stored. So const, you can't do that. So it gives you a little bit more security when you're working with strings, numbers, and booleans. If you're working with objects and arrays and things like that, it doesn't really help at all. But we'll talk about that in the future. So generally speaking, I use const by default, which is kind of a constant. If we're talking about strings, numbers, and booleans, you can't change it. However, if you're working with arrays or objects, just kind of keep in the back of your mind that it's not like a true constant. And again, we'll work more through that in a little bit. Okay, I think we're good there. Binding names. Basically, there are rules for how you can name things. JavaScript won't let you do it the wrong way, so you don't have to memorize these. Just know that if it's not letting you name it something, that there's a reason for that. But they can contain digits, but they can't start with the digit. They can use $signs or underscores, but no other punctuation. So start with this, it's a string, it's all one connected string. So like let Jimmy or whatever, it doesn't really matter. Jimmy 3, Jimmy 1, I did something too a moment ago. You just can't start with a number. It can contain $signs and it can contain this underscore as well. It can start with a $sign as well, so it can start with any of these. It just can't start with a number. There are a bunch of special keywords. We've already looked at let and const and var and things like that, but there are a bunch of others too. You can't use those as names, otherwise JavaScript doesn't know what to do. But you don't have to memorize this list. It'll tell you, and you'll be fine. So just know that there are things you can't name it, and there are some rules around naming variables, or bindings, as they're calling it here. Okay, let's talk a little bit about an environment. A collection of bindings and their values that exist at a given time is called the environment. At least in my mind, that's not a common thing that people call it a lot, but basically it's just saying you have like a set of memory and data and functions and things that you can do that exist at any given point of time, and they're calling that the environment. Inside the browser, this is important, there are actually already functions built in to give you ways to interact with your data, and we'll look at that in a little bit actually if they don't show you. But let's next talk about functions. So we've looked at like values themselves and then how to define values by a name. So like person equals Chris. That person is the name we've given it that points to that spot in memory. And now what we're going to talk about is how you actually do things with those values. Just having a value there is not a whole lot more helpful than writing it out yourself. But once you have a value in JavaScript, you can do things with it. And that's what we're going to look at here. So for example, in the browser, using the binding prompt, so this is a special thing it gives you by default in the browser, allows you to see this little pop-up window. In fact, we can run this and it should show us here. Enter passcode, like hi or whatever, and click OK. So JavaScript actually is going to pop that up for us. The browser includes all the code for that. All I have to do is use the prompt binding here that points to a function that does something. And you can see how this is like quite a bit different than just a string that equals Chris. It's actually receiving data from me and then doing something with that data. And here I'm actually passing it data as well. I'm saying, hey, it should say enter passcode. So you can see how functions are actually more interactive. They're functional, right? Executing a function is called invoking or calling or applying it. You can call a function by putting parentheses after an expression. that produces a function value. Usually you'll use the name of the binding that holds the function. In other words, we've used the name here, prompt. That's what we're going to give it, and then pass it whatever it needs. And things that it needs are called arguments. So I can pass it an argument, in this case, enter passcode. I don't think I have to pass this one an argument. Sometimes you have to for it to actually run. But here I think it'll just be an empty string, so nothing's there at all. But I could say whatever I want here, like give me your favorite number. All right, and then we hit play, and now it says give me your favorite number. So that is called an argument right here. And then the function takes that and does something with it. In this case, displays a box with that over it and with an input field that I can input directly into. All right. Different functions might need different number or different types of arguments. A prompt function isn't used much in modern programming. That's true because you don't have any control over the way it looks. And we like to make stuff look good. Console log, we've already used this a lot, but it allows you to basically take stuff and print it to the console. This is mostly helpful when you're debugging or writing your own code. You're not going to show this to a user. If you've got a bunch of console logs in your program, it just looks like you haven't cleaned up after yourself. But it is useful to say like, okay, what's going on exactly at this point in my program? Print this out to the console. So there are a bunch of other ways to console as well. You don't have to use a log. There's dir, there's table, there's a bunch of other stuff. But right now, just know that you can print stuff out to know where you're at in your program, like what your values represent. Aslan, man, what a great name. You started learning Astro. Oh, awesome. Thanks so much. That's super kind. Glad you've enjoyed the Astro content. And I also just realized I switched this locally and never switched it. What you're saying, so sorry. Now I'm looking the right way. See that? If you're still with me 25 minutes in and you've been able to handle me looking the wrong way the whole time. When a function produces a value, it's said to return that value. Anything that produces a value in an expression in JavaScript, which means that function is called, can be used within larger expressions. Okay, so like math.min, if you pass it values, it returns to you the outcome of that value. And that's what we're console logging in this case. So you can see here I'm saying, I want to know the minimum of these two, between 2 and 4. 2 is obviously the minimum. That's the smaller of the two, and add it to 100. So this whole thing is what's returned, and that's what I'm going to console log. So functions can not only take in data from you, like we saw with the prompt, but they can actually return values to you. And that's what we're showing here with this math.min. Now, where are they getting math.min from? This is another thing that's built into the language. So we'll talk about those more as we go, but there are lots of things that are built into the language so you don't have to write them yourselves. Now, JavaScript provides some things. There are some languages that provide quite a bit more out of the box. Also in JavaScript, because it's kind of slowly developed over time, it kind of looks like a house that's been built on multiple times. So there are like 5 ways to do the same thing. And there's kind of the way that people prefer to do stuff. Sometimes it's just down to preference. Then there's also like, hey, this earlier way was kind of a bad way, so we don't do that anymore. Like var, typically you don't see anymore. It's usually let or const. So there are multiple ways to do things. And a lot of times it's just preference. And a lot of times it's because the old way was bad. But here you can see that we've got this math .min function, I'll just call it that for now, that allows you to get stuff directly from JavaScript, figure out which one of these is smaller, and you can even do calculations inside of here. All right, we'll look at how to do our own functions, it looks like, in the next chapter. I think we looked at that at the beginning. But just know for now that you can return values from functions or from methods. Okay, so control flow is kind of the next thing. When you're doing any instructions, you have to be able to say, hey, if this happens, then do this, otherwise do this, right? We do that just in normal language. And so JavaScript, like any language, has to be able to define like how to think about conditionals or different logic. You also might need to have like loops where you say, hey, as long as this exists, keep doing this thing. I was actually joking with my daughter yesterday. She's 9, and we were singing a song in church, and at the bottom of the line it said repeat. And so we repeated, and then we just repeated the once, but we got down to the bottom again and it said repeat again. So I'm like, we should repeat again, and then we should repeat again. And that's a loop that happens in a normal everyday thing. And the same kind of thing can happen in JavaScript. If you don't think about those loops, you can get stuck in these kind of infinite cycles. So let's kind of think through mostly those two things. We're going to think about like splitting, branching off, or looping things. All right, so the function number converts a value to a number. I think we saw that last time. We also see string and boolean. We didn't look at those, but basically you can convert things, explicitly rather than letting type coercion happen, which is what we looked at last time. I'm not sure why I told us that here. Oh, I guess because here. So yeah, here it's saying, here's the prompt. Once I get this back, convert this to a number, and then actually do math on that number. So if we were to run this here, I could say number is like 3. This gives me the value back. I then turn it into a number and then console log out some math on that. So that's why it's telling me that. All right, so let's think through things that aren't just straight lines like we just saw. Let's think about this branching first of all, if this or that, right? So not all programs are straight roads. We may, for example, want to create a branching road where the program takes the proper branch based on some situation. This is called conditional execution. So you use this typically with the if keyword, although we actually already saw this a little bit, right? So if I come down here, oh, I forgot I made this so big. And let's see, can I get rid of that? Yeah. You might remember that we did have kind of a conditional thing already. Let's console.log, and we could say like if, I don't know, if 3 equals 3, which should be true, then produce 3. Otherwise, produce like not 3. So this is its own little conditional, right? So we actually looked at this a little bit last time, but it's very limited because you can only give it these 2 options. You can nest this, but it's kind of confusing. They're talking about more like true conditionals where you can write whole code blocks and a bunch of stuff in there. This little ternary, which we looked at in the first chapter, lets you do that kind of idea, except now we're going to do it in a whole statement here, this if statement. You'll see that this is surrounded by curly brackets. That's called a block. And everything inside of that is basically like, these are like little fences that keep all that code inside of it, which means inside here, we kind of have our own little environment, our own little, to use their word earlier, we have our own little environment inside there with its own scoped variables and things like that. So we have the number out here, but it could also reference other things inside here, and stuff inside a inner scope actually overrides stuff on the outer scope. So if I wanted to, this would not be wise, but I could say like, let the number here equal like 1 or something like that. Now, as soon as I do this, it doesn't really matter what I put here. I could put 12 and it should return to me this instead. 1 times 1 is 1. So this inner scope is going to override anything on the outer scope, which is another reason I don't like using let unless I absolutely have to, because here I basically have 2 things named the exact same thing that point to different values in memory. So you have to be careful when you're naming things. That's just a little kind of getting ahead of ourselves here. Okay, but here what we're going to say, we've already done this. This is what we've done already. But what we want to do is think through like optional things. So let's skip down here. A block, that's what we talked about a second ago. Okay, cool. So this is the same kind of logic we looked at earlier. 1 plus 1 equals 2, then console log it's true, but there's no else. There's no other thing we're doing. And down here, you see that we can actually do an else statement as well, and it looks like this. The syntax right now isn't important, it's just the concept. So don't worry about like, where's a, semicolon go, or where's, parenthesis go, or a curly bracket. Don't worry about that right now. Just think through the logic instead. In fact, maybe we can extract this out into some kind of TL draw thing. So the idea here, we're doing something. Let's get rid of all the rest of this stuff. All right. We're doing something, and at some point we're going to have a question like, is this true or is this not? So maybe we come down here, we ask the question like, is this Joe? All right, so this question determines which path we take. And all we need to know right now is that in JavaScript, you can say yes or no. If it is, do this. If it's not, do this. So yes, then do something over here. Otherwise, we're going to say no, then do something over here. And this whole thing could be done in a few ways, most notably with the if block. So we'd say, if this is true, then do this. And then you can also have an else. So if this is true, do this. Otherwise, do this. Now, as far as logic goes, typically, if you have else statements, they're just a little harder to read. And so it's usually best to say, like, let me just take one option out. And if that doesn't exist, then do the other option. So typically, you want to limit the else statements and just keep these as if statements. So let's actually maybe look at another example here. Let's get rid of all this. I'll come up here and like we could say something like, I don't know, const name person equals Chris, like that. All right, so now what we can do is we can do an if statement. We can say if person equals, and we'll say Bob or something like that. Now, in this case, I want to know if this one thing happens, then do something. So let's come down here. We could say like console.log. Bob is awesome. All right, whatever this happens to be. Oops, I hit enter too early. Like this. Okay, cool. So now what I can do is say, if this is true, do this. Now notice nothing happens here. It's undefined. So I could come back up here and let's re-add this in and say else, then any other case, all right, we're gonna have another block here. Again, the syntax doesn't super matter right now. We could say like, Bob stinks. If I can spell, goodness stinks. It's too early. All right, so now it says Bob stinks. Sorry, Bob. So this little else statement, we could write like this. The other thing we could do is do 2 if statements, right? So this could be a little cleaner depending on what you're thinking. Oops. There we go. So right inside here, I'm going to take this. We're going to go if person does not equal, remember we looked at that last time, Bob, then console log Bob stinks. Now, it's up to you which one of these is more readable. But here I'm saying, if this is true, then do this. And then I'm like, else. Well, what are we else? Especially if this is really long. Like, let's say we have a bunch of stuff in here. I have to scroll back up. Like, what was the first condition? So a lot of times it's cleaner for people if you just do, if this is true, then do this. Otherwise, if this is true, do this. All right. So here we've covered all possible use cases and only Bob stinks will be printed, right? Only one of the 2 will actually work. There are other ways to handle that as well. But just to note that you don't have to use else statements. You can just do 2 ifs or one right after the other. Okay, back over this way, you can do else, then you can do else if, and then you can do else as like a final thing. And again, this starts to get kind of muddy at some point. So typically if you're doing multiple things like this, there are other ways to basically give different options and say, here are all the different options. If this is true, do this. If this is true, do this. They may talk about it, but it's called a switch statement. So we'll look at that maybe in a little bit. The program will first check whether num is less than 10 up here. If it chooses that branch, it shows small and it's done. If it isn't, it takes the else branch, which contains a second if. If the condition is less than 100, that holds. That means the number is at least 100, but below 10, and medium is shown. If it doesn't, then the last one is chosen. Now, whenever you're doing logic like this, you do have to think through, okay, what order is it going to go through? And at the very beginning, we read that it was going to go top to bottom, and that was going to read out exactly what's going on one after the other, which means you have to think through your logic. If you console too early or cut out the logic too early, it'll never get to the later stages. So in other words, if I came inside here and I said something like, if it's greater than, let's maybe do less than 100 to start with, and then we'd say medium. And then we say, well, if it's less than 10, then I want to do small. If I try to do this, it'll never ever get here, even if the number is like 3 or something. So if I say 3, you'll see it says medium. Well, it is less than 100, but you see how I kind of shortcut the whole program? So logic is really important, thinking through, okay, what thing is it going to ask first? And is this the only condition it meets out of my different options? So whenever you're doing, whether it's if statements one after the other, although there you get them all printed, right? Or in this case, it's going to go through this second one only if the first one isn't met. Okay. Let's look at while and do loops. Like I mentioned up front, this is not used a ton, so I won't spend a ton of time in it, but you could do console log 0, 2, 4, 6, 8, 10, 12. But when you write a program, you want it to do it kind of by itself and be able to be like more flexible, where you can pass in any high number and it logs up to it, every 2 or something like that. All right, so what we need is a way to run a piece of code multiple times and a little loop to do this over and over again, right? But we want to be able to exit that loop once a condition is met. If you don't do that, then it will just crash your browser or your tab or something like that. In fact, let's go crash our tab. Well, let's look at the example first, then we'll crash the tab. All right, so we could say let number equal 0 while number is less than or equal to 12. That's the syntax there. Console log the number, and then take the number and change its value to its current value plus 2. So it's going to go 0, 2, etc. Number is less than or equal to 12. So if we run this, it should give us the exact same thing. Now let's go ahead and grab all this, and I'm going to come down here, and we'll add this here. This should work the same, right? It's going to print off all those things. Now, it printed 14 too. Not totally sure why I did that. All right, let's come inside here though. And let's just say while there is a number, and I should say, let's do this somewhere else because otherwise we're going to crash this tab and then I'll have to open it up again. So let's come over here. Let's go back to my Google, or I had it here, didn't I? Yeah, here we go. So let's go down here, get out of here. We'll print this, and this should crash the program because it's going to try to do this. Actually, is it trying or not? Let's say is less than infinity. So it's just going to do this infinitely, which again should crash the program. So eventually this starts to slow down and the whole tab will crash. So if I try to refresh it, it'll just die. Look how it's just continuing going. So we need to kill it if it'll even let me. There we go. So you do have to be careful that you have an exit strategy. Otherwise it'll just keep doing a thing. This while creates a loop. The word a while is followed by an expression. All right, while this, and then it just gives you stuff inside of here. Every time the loop repeats, it gets a number added to it. We already looked at that. So here it's showing you the counter where the thing currently is. I guess it doesn't print this off for you, does it? So we could say counter and then get that logged off each time. So it's actually showing the progress. This is each individual loop. So the first loop it's 1, second time through it's 2, second time or third time 3, 4, 5, 6, 7, etc. All the way up. All right. So that's the counter of what it's actually multiplying time by. And then at the end it prints off the final result down this way. So this is the number of loops we've gone through. You can see here they're saying you could have started at 1 here, the counter at 1, but generally you start programs at 0. And we'll talk about that later, but basically it's the way that things are typically counted in a lot of programming languages. You start at 0 and kind of go up. All right, it has an operator for exponentation. I can't speak this morning, which it used to compute this code, but it would have ruined our example. So we could have just done it like this instead of like multiplying the result times 2 or whatever. All right, there's also a do loop. Again, this is not something that's super commonly used. While is probably used more common than like a do while loop. Do loop always executes its body at least once. So it's first going to do something and then it'll have its condition. Usually, again, you do this in other ways. At least this is the way typically people write JavaScript today. Same kind of idea though. It asks who you are, and then after that, while something exists, it does something else. But it first gives you an actual thing to do. I think that's confusing and not helpful. Yeah, basically, you can use the bang operator to convert a value to a Boolean type. So this is basically saying, does this exist? All right. While it exists, then print that out. So it's turning this into a Boolean, like yes or no, true or false. Does it exist? Well, it doesn't turn it into it. Just in this little tiny statement, it's turning it into it. Is this true or false? That's all it's asking. And then the value still remains the same, whatever the name is that you put in. Indenting code. This is not super important because your code editor should do this on save. Usually people use spaces or tabs. There's an accessibility concern if you're working with other people, but right now just know that typically if you can structure your code to kind of be the logic. So if you're doing something, then kind of, if this is true, then the next statement should be inside that. And this just kind of helps you logically break this down. You don't have to do this. So I could come over here and this could all just be like this. Oops. Technically that could be on that same line, but you can see how it's a lot harder to tell what's going on here, right? And then if I hit play, same exact thing should happen, but we don't have the formatting, right? So it kind of messes us up. Reset the sandbox. It doesn't even put the formatting back. Okay, so we've looked at conditionals. That's like, if this is true, do this. If this is true, do this. We've also looked a little bit at some looping with this while and do loop. The more common way to do this is with a for loop or a bunch of the methods that exist, which we'll talk about later, which are basically functions that exist on things, right? Without getting too complex. A counter binding, let's see, many loops follow the pattern show in the while example. For first, a counter binding is created to track the progress of the loop. Then comes a while loop, usually with the test expression that checks whether the counter has reached its end value. So we looked at that a second ago, right? Up here, let's see right here, this counter value right here. this is what's evaluated first. If this is true, then do all this stuff. Otherwise, you're done with the while loop, right? So there's other ways to write this. At the end of the loop body, the counter is updated. Okay, because this pattern is so common, JavaScript and similar languages provide a slightly shorter and more comprehensive form called the for loop. Now, honestly, a lot of people don't really use the for loop either right now. This is, it's like you need to know how to use it, but there are other things that people typically use, but this is kind of the traditional way to do it. So what you're going to do is define your own counter here. Same kind of thing here, where we bind something, we're just going to bind it directly in the for expression. And there's 3 values it takes. The first thing is whatever that binding happens to be. So you get to name this whatever you want and set its value to whatever you want. The next thing is what you would do inside the while little parentheses. You'd say, okay, like give me a condition under which this is met. And then the final thing is to say what to do each iteration. So this kind of packs all this together right here instead of having to write it out yourself. So up here, we had to write all this out inside the while loop. The for loop just says, I know you need those 3 things, so let's just do it all in one expression. So give me the variable, tell me what the condition is, and then change the variable as you go. And then console log it down here. So the only thing we're doing in the actual for loop is just console logging, and the same exact thing should happen, right? 0 through 12. So this program is equivalent to the earlier version, but it basically encapsulates all the logic in the actual loop structure itself. So same kind of thing, we take this and try to do the exponential updates of the variable. Here we're going to define the counter at 0. We're going to say here's the condition, and then here's what you should do each loop, assuming that you're still in the loop. And then the result equals the result times 2, right? And then you were just going to console log it at the end. We could come inside here because I've got access to it. Can I actually console log the counter? Yes, we can. So we can come inside here and the same kind of thing, right? This counter is passed down and we can actually use it inside of the for loop as well. This is the variable, the binding that we set up to start with. Now you can break out of a loop in a couple of different ways. You can just break by using the break keyword. There's a couple other ways to do this as well, but usually you're going to use this condition, whatever the condition happens to be. And notice we've got this condition, all right? Let current equals 20, but there's no condition set here. So it's just an empty condition, which is why we have to have some kind of if statement inside of here. So as long as what we really want to know is, can we still, is this still divisible by 7? So we could have just put this up top here, right? So we could have done this up here, and then we could have done that. Same exact result should equal, current, see if I mess something up. Divisible by 7 equals 0. I'd set this to 21. Yeah, now we get 21. Okay. So we could have put the logic here. They're just showing that you can also do additional logic inside. So we could have branching inside of here or even loops inside of here. So you can get more nested and complex, but you can break out of it early by using this break statement. So that's for more complex logic. But yeah, and the remainder operator we looked at earlier as well. They're warning about infinite loops. I talked about that earlier. We kind of showed that real life example too, how you have to make sure you exit somehow. Otherwise it'll just keep doing the thing forever, right? Until it can't handle it anymore. Eventually you'd run out of memory on your machine and it could crash stuff, but the browser's going to kill it before it gets to that point. But if you're running like code somewhere else, it may not. You may have bigger issues. Okay, updating bindings succinctly. So we looked at how you can take counter and say counter equals counter plus 1, which increments the counter by 1. But because that happens so often, you can actually do this little shortcut of plus equals 1. So if I do counter plus equals 1, it's not referenced anywhere, so we'd have to start with something like let counter equal 1. And then let's go ahead and console.log the counter. And then let's just copy this down and we'll do it one more time down here. So first of all, we're going to say, hey, here is the name of this value, 1. I'm going to call it counter, log this. Then I want you to take counter and add 1 to it. And this plus equals 1 is a shorthand to do that. Now log this a second time. So we should have 1 and then we should have 2, right? So this is a little shortcut, just like that for loop is a shortcut for the while with all the extra logic based inside of it. Here we can shortcut changing and incrementing the value. This allows us to further shorten the example. So let number equal 0, number is less than or equal to 12, number plus 2, or plus equals 2. So add 2 to it, increment that. For counter plus equals 1 and counter minus equals 1, there are even shorter equivalents like counter plus plus or counter minus minus. So if you just do plus plus, it'll add 1. Otherwise, you have to actually define what the number is, like what they did right here. But we could do, if we knew it was just going to be adding to it, if I can type plus plus, and then it's going to increment by 1 each time all the way to 12, right? Instead of by 2 each time. If we want it to be 2, we'd have to either do equals number plus 2 or that shorthand plus equals 2. Or sorry, equals, what am I doing? Oh, I left that one in there. There we go. Okay, so, they do talk about switches. So you might remember I said like sometimes you have lots of different options and you want to say like one thing for each of these. And this gets kind of like hairy, right? If this, then this, else this, then finally a default action. So typically you would use a switch statement instead, and you're going to define every possible case. And again, the syntax here doesn't matter. Just think through the logic. That's what matters right now. The switch is basically a way to break down the different options without doing a bunch of nested if loops, if statements. So we'd say switch, here's the prompt, what's the weather like? And we only have a few options. If we say rainy, then do this and break from it. That's our keyword. Then do this. And if it's this, then do this. And this should, I'm not sure why this doesn't say break. This should have break there too. And then if it's cloudy, do this. Otherwise, for every other use case, just say we don't know what the weather is. So if I come in here and we say something like rainy, and then I say, okay, it should say bring an umbrella, right? And then it just breaks out of this loop. So it's going to give all the different conditions directly inside of here. And you can see how easy this is to read versus like a huge string of if statements, right? So I'm going to say, if this is the case, do this. If this is the case, do this. And you can have multiples of these on here. So you could say like case rainy. And I don't remember how to do this, actually. I don't remember the syntax. Maybe it's just and. That doesn't make sense. And I can't type and either. All right, cloudy. Let's see if this works. I don't think it will. Rainy. I don't remember the syntax, sorry, because I don't use these a ton. Unknown weather type, yeah. So it doesn't really know because I didn't do that right. See, case this. Ooh, I think I remember. Or case cloudy. I think that's it. Let's try it again, just in case. I'll say cloudy. Oh, I forgot there's a cloudy down here. Let's say like hi. It doesn't really matter. Okay, so come back here. We'll say hi. Let's see if it says remember to bring an umbrella. Yeah, okay. So this is the way you set off multiple cases. And that's super clear. Again, you can see exactly the options you have. Let's see. The program will execute at the label corresponding to that value or default if nothing is found. In some cases, such as sunny, this used to share some code between cases. It recommends going for both sunny and cloudy weather. Oh, okay. So they're just saying sunny can, that's why they didn't have the break there. I don't know. I don't think that's a good thing to teach people. So it's saying it's printing both of these because there's no break. Okay. Typically you want breaks. It's easy to forget a break, which will cause your program to execute code you don't want. So always have a break when you're writing a switch statement. All right, talking a little bit about how to capitalize or name variables. So rather than like rules, this is more like how to make your variables readable, your names readable. So fuzzy little turtle, that's kind of hard to read. You could do underscores like this. You could also do capitalizations. This is typically what people do in JavaScript. You could start with a lowercase and then capitalize the next words, which is kind of the default in JavaScript. So usually you don't start with a capital letter. This is typically what people do. The underscores is obviously easier to read, but it's not the best to type. And I think they even mentioned that right there. Most JavaScript developers follow this one, although people are changing all the time. But yeah, that is one thing you can do. Remember only underscores or dollar signs. So as far as special characters. Comments, if you want to comment things out, you can use this double slash. Usually you do command and then the slash character. And that does your comments for you. So let's see if it'll let me do this here. Yeah, so it just does it for you, so you don't have to remember to type that. So in any section you're in, even if you're in a whole code block actually, let's see if it'll let me go inside here. So I can grab this whole section, do my command, and then it'll take care of adding all that for me. So you shouldn't be manually typing those, just use the keyboard shortcut command and the /. You can do whole blocks like this. where you have a whole block of text, and that's all inside of here. Okay, so back to our summary, and then maybe we'll do a quick exercise. We know statements. Those are little tiny like fragments of a sentence. We have expressions. Statements are the whole full things. Expressions are the little fragments. And you can remember that because statement and sentence starts with the same letter. You can put statements one after the other. Just know that they go from top to bottom. And unless you use an if or an else, a switch, like those kinds of like branching ideas, or a loop, while do, or the for loop, that kind of embeds a lot of that there for you, like in the expression. Bindings can be used to file pieces of data under a name. Those are the variables we looked at a moment ago. And then they gave some examples of how to name those. Functions are things that, like little programs that can do things, and you can pass them arguments, and then they can return to you values. And we'll look more at those in the next lesson. Okay, if you're unsure how to test your solutions to the exercises, refer to the introduction. Each exercise starts with a problem description. Find full solutions here. Okay, cool. So let's think through this little while loop here. We want to be able to pass it any number, and we want to print out, like, the first time one of these hashes, the second time two, the third time three, whatever, as many as we have. You can find the length of a string. Okay, well, let's talk a little bit about like values that exist on things in JavaScript. So if I come down here, or things that already exist in JavaScript, I can have a number like 3, and usually the way you reference what I'm going to call methods right now, because that's what they're called, but functions that kind of exist on a certain type, in this case, a number, or functions that exist as part of a class, which we haven't talked about yet, but basically built-in functions, whether you wrote them, a program, a library you're installing wrote them, or they're just built into the browser. You use this little dot character. Now what this does is it gives you access to additional items. All right, so maybe let's make this a little cleaner. We'll say const num equals 3. And now I can say num dot, and if I come inside here, you'll see that it knows it's a number, right? It already knows it's that type of number. And look at all the stuff I get by default. To exposition, to fixed, to local string, to precision, to string. Like, what in the world's going on here? Well, this is all built into the browser. If I have this, and let's change this. Actually, let's have const my string equals Chris. I can say my string, and then notice if I do dot, it's going to give me different things like at or big or blank or char at or concat or construct or fixed, or where are all these things coming from? Well, these are actually, they live on the idea of a string here. And so I can do things inside of here. So I could like dot length, and it says your string is 5 characters in length. Now JavaScript builds this in by default so that you don't have to build all these little micro functions basically in to figure this stuff out. You could write your own thing to say like, count how many items are in this string. But why doesn't JavaScript just provide that for you? And that's what the dot length here, in this case, property is for you. So it's going to figure that out and just give it to you automatically if you do length. And that's what they're saying in the example. Now this is really helpful depending on the type of data you're working with. So I could say like const my date, for instance, and say like date.now. You don't have to know what that does. All you have to know is that when I do my date here, it knows that this is a date value, and it gives me all these different examples. So I could say, for instance, to locale string, and look at this crazy thing. It's gonna, let's do to locale date. Oh, it's because I did dot now. Sorry, ignore me just a second. Const my date 2 equals, we're gonna do new date. Sorry, I was getting ahead of myself and gonna show you something else we could do, but we'll do my date 2. Date 2. Come on. Okay, so now it knows that this thing is an actual date. So I should be able to say to locale date string, and it turns it into a nice little string 9/15/2025. This is how I'd write it in the US. Some of you would put this first, but that's not important. What's important is the browser knows how to convert this for me. Now, if I go back to my date here, this is, oops, my date. This is a number, even though I started it as a date, date.now. And that's because it gave us what's called epoch. Without getting too complex, we'll learn about all this later, so just ignore me if you're like, I don't care. This is the number of milliseconds since January 1st, 1970. Why that date? I don't know. I'm sure there's important history to it. The point we know is that this is a exact number for my millisecond when I typed that in originally, and it stored it in memory for me. And so I can turn that number into a bunch of different things. For instance, I can say to string, and it turns it into a string like that. I can even do to, actually what I can do is take all this and say new date, and I can pass it this variable right here. And notice it passes the exact millisecond in, new date knows what to do with it, and it converts it for me. I can even then come off the back of this and say, give me the date string here. Or I could say, give me to locale time string. All this is just built in by default in JavaScript. And you'll learn how to use these, but evidently I did this exactly here in my time zone. Okay, so let me shut that down. And that's all they're saying here is that some things are built in JavaScript. And you'll learn when to use them and when not to use them. Basically, when you start to do stuff a lot, you should ask the question, is this built in JavaScript? Am I writing this for no reason? And a lot of times those kind of really basic information things you need or conversion things are built in by default in JavaScript. And they actually keep adding stuff to it. They added a bunch of new stuff under the internationalization API not too long ago, a few years back, and that massively helped converting between strings and time zones and currencies and that kind of thing. Okay, so we've got this variable ABC, and I want to basically print off however many items I need here. So let's write our code. Let's define our own variable. We're going to say like string equals, and I guess I'll just do Chris because I've been doing that so far. So this little statement right here, our expression, what we're going to do is grab that variable and we're going to do some kind of loop, right? That's the kind of problem it is. It's not a if this, then do this. It's a loop kind of problem. So there's a couple different ways we could work with this, but probably the easiest is that for loop, right? Because it contains everything we need in its own logic. So the basic structure looks like this. And again, syntax isn't super important. It's more remembering like there's a way to do this in JavaScript. You can always look up stuff. The first thing we want to do is define a variable. So we'll say like const or let, because we need to change it, let x equals 0, all right? Then we'll have three sections here. We have a condition. We want to know if x is less than or equal to the length of Chris, all right, that string. So I'd use string.length. Remember, that's something that JavaScript gives us by default. It'll give us the length of that in just a number, all right? If that is the case, then it should keep going through this loop. And every time it goes through the loop, I want to do something to x, and that is I want to iterate on it. So I could say x equals x plus 1, or I could say x equals plus equal 1, or remember, we've got this real shorthand if you're just incrementing by 1, which is plus plus. So I can just come in here, we'll say console.log, inside of here, x, like that. So now I can run this, and you'll see we've got a problem, because I've just been printing x. And what I want to do is add to this multiple times. Well, here comes one of those extra helpers, right? Because I can just say like x times whatever, but that is a string. I can't multiply strings. So there's another little helper we get called repeat. All right, so what I'm going to do is take the number I'm currently on, so x, repeat, like this. Or no, I did that wrong. I think the way that repeat works is you take your string first. So the string would be whatever this is, right? The x is what I want, or no, we wanted a hashtag. Then I'll do dot repeat, and we're going to repeat it a certain number of times. The number of times is what we're passing here, and that would be the current iteration we're on. So we do x. And again, how are you supposed to know that right now? Well, you're not, but I'm doing this right now just to show you what you would do here. So I'm saying repeat this many times. And again, this is one of those little tiny things that you might be tempted to write your own program for, but JavaScript has it built in on the string itself. So now I've got it like this, and which means I can change this to be whatever I want. However long it is, it'll just work through my program until it hits the end, right? So this little for loop, we could also do this with the while loop as well. We would just have to do this logic inside the while loop. So maybe let's convert that over. So we'll say while something is true. Here we're going to say while x, actually I'm going to need to set x outside of here. We'll say x is equal to 0. And then inside this little thing, we'll say while x is equal then or later or greater than string dot length. Then I'm going to print this. And now I have to add x to, plus plus down here. So this should work the exact same. Let's just change it to make sure that it's actually working. Yeah, so it should work the exact same, but it's a little messier than a for loop, which is why people typically like to just contain all the logic in the for loop, and then you know exactly that you're iterating properly, you are properly incrementing if you need to do that. There's a couple of other examples. It's hard to do a lot of these right now without knowing some of these things that JavaScript has built in. So for now, just know that you can branch and you can loop, and you'll figure out kind of some of these helpers if you want. If you want to work on these, go for it. I'd encourage you to make sure you know what's available to you in JavaScript as far as like just look up, is there a way to repeat a string value multiple times? And you'll find that as much as possible, I would encourage you to use AI more as a helper to explain stuff you don't understand and less as a give me the answer to this, because then you're not actually doing the process of like figuring out what you need, what's the logic, that kind of thing. Okay, so this is chapter 2. We looked at the program structure. The next one, see, do I go here, go out? Yeah. The next one over here is data structures, which is objects and arrays. We've talked about this already a little bit, but now we'll get the chance to actually work on it more kind of like full time. All right, well, hopefully that was helpful. I'm gonna switch over to my camera here. Sorry for the video being on the wrong side to start with, but yeah, I'll remind you, I guess real briefly, I should go back to my split. I'll remind you real briefly here about my campaign for childhood cancer. I mentioned at the beginning that I've got like 37 prizes, and I think I only have like 6 or 7 people who've sent me their receipts. So I've got a ton of prizes left. For those of you who give, you get a raffle ticket for every $5. So if any of these seem interesting to you, like Cloud Cannon, Console Ninja, Dracula, Git Tower, my own Astro course, Mux, Neon, Quokka.js, Vercel, Wallaby, Warp, all of these are basically giving me software to give to you, which I want to say a huge thanks to all these companies, because hopefully it helps incentivize you to say, yeah, I could give $5. And if everyone gave $5, we could really make a huge impact, especially on international care for children with cancer. And that's kind of the push right now, is how can we spread the research, spread the actual cures the world over, especially to areas that don't have ready access to medical care. The next 7 years is a huge push for that for them. They've got a target in mind, and all the funds we're giving help contribute to that kind of a mission. So hopefully you'll join me in that. But thanks so much for following along. I hope you enjoyed our time together today. And I know this is beginner JavaScript, but hopefully it helps to kind of talk through it together. And yeah. All right, Nick, sorry, I just saw your comment about another mic being used. It's possible. I think it's this one, but yeah, sorry for the trouble if that's the case. Well, thanks for following along. I think Friday I will be gone, but I'm going to try to pre-record chapter 3. So hopefully we can do that, and you can watch it Friday live, even if it's out of time. All right, thanks so much. I'll catch you in the next one. Happy coding.